So I want to do some comparisons and more with intermolecular forces. In this case, rationalize the differences in boiling points. So this is kind of good to kind of tie together everything we've had in the previous videos. Let's look at pentane and hexane. So both of these are carbon hydrogen. So both of these are going to have LDF. And they're nonpolar. So carbon hydrogen compounds, the alkanes they'll call them, are going to be nonpolar. Notice that hexane has a higher boiling point than pentane, and the reason is this has a higher molar mass. That's why. So if the intermolecular forces are the same, you can make comparisons with their molar masses. The higher molar mass, that usually trumps everything else, to be honest. That's going to have the higher boiling point. Let's take a look at this one. HCl, lithium chloride, HF. The reason lithium chloride has the highest, by far, ionic compounds. They always have the highest. Those ionic forces are the strongest. So that's the reason for that one. Now, if I look at hydrogen chloride and HF, this is something we actually we talked about in a previous video. HF has hydrogen bonding, and that's going to cause it to have a higher boiling point than hydrogen chloride, which is just dipole-dipole. So again, we're just looking at it and trying to tie together stuff like molar mass, intermolecular force, etc. Let's take a look at this one. So in this case, I'm looking at pentane and neopentane. They both have the same chemical formula. These are called isomers of each other. So same molecular formula, but different structures. If you look at this one, this is what we just did pentane. Pentane has a boiling point of 36. Neopentane has a boiling point of 9.5. So they both have the same LDF forces. They're both nonpolar. And LDF and the same molar mass. Now the reason this is lower has to do with structure. This one right here, because it has kind of a tight structure, has less surface area. So I'm going to call this kind of a tight ball structure. This one is more spread out, more surface area. So even though they have the same molar mass, this is tight balls like this will have a lower boiling point than something that's kind of spread out like this. And you'll see this throughout organic chemistry.